Hello all, welcome to the Linux Rootkits for Red Blue Teams course on Pentester Academy. Now in this video, we'll continue with kernel module basics and look at how we can play with parameters we pass to kernel modules using sysfs. So let's jump right in. Now all of us have probably seen the proc directory, right? So if we go into our VM and we go into the proc directory, we can see that there are a ton of files in here. So what are these actually all about? Some of you may know what it is, but for others, well, /proc is actually a virtual file system which is created entirely in RAM. And this contains a lot of runtime information which the kernel actually ends up sharing with the user space. Now, some of this information is read-only so that user space programs can, look at that information, display it, show it, etc. And in some cases, it is possible for user mode to actually write to those files and which may affect changes in the kernel. Now, the original idea of /proc was actually to provide information about the running processes from the kernel side to the user space side. So very old versions of the program PS were actually using /proc to go ahead and display information about running processes. Now, even though it kind of started off as sharing runtime process information, it quickly ended up morphing into a dumping ground for pretty much everything, right? So if we actually go and look at different files, we can actually see the CPU info file, which has information about the current CPU. If you look at call sims, this is basically all the symbols which are currently there in various modules in the kernel, or whatever the kernel actually exports, pretty much everything. And there are so many other informations, right? Now, these directories which you actually see with numbers, well, the numbers correspond to the process ID. And if you go to any one of these, let's say 4317, do an ls. Of course, we have to be root to be able to see some of the stuff. We can actually see that a lot of information is actually available about the running process, right? So what ended up happening is it became very, very chaotic. It became a dumping ground for pretty much all runtime information even about the hardware and whatnot. And because of this, it also ended up becoming very, very unstructured. And this is really where people said, it's going to be very difficult to clean up that mess, immediately. So why not just go ahead and, start working in a direction which is much more structured. And that's where they created, the /sys or sysfs. And sysfs typically gets mounted to /sys. Again, this is nothing but a virtual file system created entirely in RAM. The key difference, though, is that sysfs actually maps the different kernel subsystems, device drivers, and more importantly, preserves their hierarchy. So this allows us to navigate sysfs and look at these different things in a much more hierarchically correct order. Pretty much every single K object or kernel object actually is mapped to a file in sysfs. Now, the important thing to note here is sysfs is not a full replacement for /proc. And right now, both of these will coexist and, providing different useful information. So let's actually look at the sys directory. And we can see that this seems a lot more organized even at the root sys folder. And if you go inside module and do an ls, we'd actually find that every loaded module actually has a corresponding, directory in here. So just to give you an example, if we were to load our hello world module, and then we go to sys modules to an ls, should be able to find your hello world module show up as a folder. So let's go in there, and you actually find that different information about this module is actually present here. So for example, the reference count currently is 0. So all of this is kind of mentioned in here. Now, why is this important? Now, in the last video, if you remember, we had talked about module input parameters, etc. Let me go there. And we had seen that the third option in here, which is perm, we had taken as 0. Now, if you notice, the help file actually tells you if perm is 0, then the variable will not appear in sysfs. But if any other permission is actually granted here, then it will appear in sysfs with that permission set applied. So what we would like to do, if we would just go out of this directory, go back to class, and then go back to this video's directory and open up the C file. So what we would ideally want to do is now these two parameters which we had looked at in the previous video, counter and message, we want these parameters to be available in sysfs, and this is the permission we are giving it. I'll talk about the permissions in just a bit. And based on that, it will be possible for us to change these values even at runtime. So in the previous video, we did an ins mod and we assigned different values to these variables. And of course, we couldn't change it anymore. However, if we map these to sysfs and give appropriate permissions so that the root or other users can modify these, then this can be modified at runtime. So let's try and understand the permissions. So of course you have the core base permissions, which is, if you look at how to kind of read this. So we have read, write, execute. So s_i, RWX stands for read, write, execute user, right? U for user. Another option we have is, R user, which is this read user, W user, which is write user, and X user, which is execute user. Similarly, we actually have read, write, execute for the group, and then read, write, and execute separately for the group, and then others, right? And then we can take different combinations of these and then create, other combinations like read, write, execute, user, group, and others. And this is what this would be, an OR between all of these, and so on and so forth, right? So these are located in these directories. So inside include UAPI Linux stat.h line 30, this is what you'd find. And under Linux stat.h, you'd actually find these other permissions as well. So what I've done in this sample code compared to the previous one is just replace the 0, which ended up forbidding a sysfs entry. So replace that 0 with this permission. So what does this permission say? s_i. You're saying write for the user and read for user, group, and others, which means the owner, which is root, will be able to write to this. Everyone else can read. And we do the same thing for message as well. The user can, with root, can write to it, while everybody else can read. Now, let's go ahead and see what happens. So I already pre-compiled it, but I'm just going to do it once again. And then let's actually do a sudo ins mod, and then we can do ko. I'm going to say counter equals 100. Actually, before that, let's actually clear the message cache. Make sure there is no messages in there. Great. Let's This makes it easy for us to actually work with the demos. Let's put counter equals 100. Actually put message equals hello world. Okay. And if you do a D message, as expected, we are seeing counter is 100 and the message is hello world, right? Now, if we go inside the sysfs directory and we go inside modules, and you'd actually find that there is a module for hello world sysfs param. So we can go inside that. And notice that now a new folder appears called parameters. Do you see that? So let's go inside parameters, and we would actually find that we see counter and message in here. As you can clearly see, permission wise, root basically has read and write both, while everybody else only has read. So if I do a cat counter, I see this value is 100. If I see cat message, I actually see the value is hello world. Fantastic. So actually open up another terminal. Let's open up the code here. Now, what we've additionally done is, apart from the printing in the module initialization, I'm also printing this when the module is about to exit once again, right? Now, in the normal case, if I were to go ahead and just do a sudo rm mod hello world underscore sysfs param, then if I do a D message, it actually find that the parameter on exit is pretty much still the same, right? As expected, counter is 100 and message is hello world. Okay. Now let's actually insert this once again with actually the same values. Looks like I'll have to sudo ins mod ko. Let's actually put counter equals 100, message equals hello world. If I do a D message, of course, I should be able to see the 100 and hello world. Now, if you go to sysfs, become the root user. I had to go out of it once and then go back inside it again. And we can see the value of counter and the value of message is pretty much what we passed during module initialization. Now let's actually do an echo 200 inside counter and echo hello world to message, right? And now when we go back to the other terminal and remove the module, and do a D message, what you'd find is now the changed values are being printed right on exit, which is counter is 200 and the message is hello world. So if you notice, the best part about actually allowing the parameters to be mapped into sysfs is that we can change their values at runtime. Okay. And much later, you can even look it up yourself, how you can create entries in sysfs, monitor changes, and get informed by having different getters and setters and whatnot. Now, for our purpose, this is good enough for now. As I said, we aren't trying to become a Linux device driver programmer. The whole idea is to know enough about kernel modules so that we can start programming and looking at rootkits. Anyway, so this is very, very important because, as I said, we are going to be playing with many of these parameters as we move along. Great. So that's all I had in mind for this video. If you've enjoyed this, please do recommend to your friends and colleagues in the InfoSec community. Thank you.